Hi everyone, so in this video we'll take a more in-depth look at the firmware on the MMU2, so on the board that controls the MMU2. So if you want to go directly to that, you can skip ahead a few minutes, but I just want to update you on what I've been doing in the past week, or at least not doing. So I have not done much for the project because I had a lot of stuff going on. I had my graduation, and I was gone for an entire week in a place without any internet. But during that time, a few things happened. So I received the board, so the SKR Pro V1.1 from Big Tree Tech. This board is really amazing, and I've already set it up and installed Marlin on it, and it works great, and I think that this will fit perfectly our application. I've also received a little screen to go with it, and this way we'll be able to work on that. I am going to upload a few videos in the next weeks because I will be able to start working again on my project, because I don't have anything happening in my personal life anymore. So yeah, I'm glad to be able to continue working on that, and let's get right into the video.
Okay, so now we'll take a look at the MMU2 firmware. So there's a board on the MMU2, and there's the process firmware on there, and this firmware basically controls everything. So this is what loads and loads filament, checks the different sensors, and this is we need to implement the features from that into Marlin if you want to make this work. So basically how the entire project is working is that we are basically using a single board to control both the MMU2 and the printer. So on this board we will run Marlin to control the printer, and then we need to adapt the Marlin firmware in order to use our multi-material upgrade. So this is why we need to analyze the code that is on the board of the original MMU2, because we are basically trying to reproduce that board inside Marlin. So as you may know, most of Prusa's products are open source. So this means that we have access to that entire code, which is extremely useful for us, and we're going to dive right into it and go look at this program. So the VM code folder is not really super interesting for us. So it basically contains lines of code that are used by the IDE. So if we look into that, you can see it's basically a lot of junk, and it's simply used during compilation, configuration, and upload. And we don't really need to go deeper into that part of the project because it's not necessary. So the next folder, the next two folders actually, are PIO builds and PIO lib deps. So these are the platform IO related folders. One is for the final build, and one is used for the library's dependencies that are downloaded when compiling the program using platform IO and uploading it to the board. So that's why I actually don't have anything in the libdeps and not much in the PIO build. It's because I've just reopened the folder, the program in VS Code, and actually I've just downloaded the PIO extension. So this is why I've not yet built the project, and because nothing is showing up in any of these. So the next folder is the like development environment. So it's everything related to VS Code. So once again, nothing that we really need to look at in order to understand how this works. So the next folder is a bit more interesting. So this is where all the board pins are defined. So we can take a look in there to show you how it works. So the board used by the MMU2 is based on the AVR ATmega32U4. So this is basically an Arduino Leonardo with stepper drivers integrated into the board. Since it is using this AVRT Mega, it has a special pin mapping, as you can see here on the little comment in the side of code. This is why it is a bit different from what you see in other Arduinos and boards. So next we have the catch folder. I seriously need to do more research about catch and catch 2 in that case, but it basically seems to adapt the code to different platforms like Linux, Windows, and seems to be here for compatibility reasons between development environment and OS. So if you know exactly what this is used for, just tell me in the comments, but this is what I found out just from looking at it, and I don't really want to use any time on that right now, but I will sure to take a look at it in the future. So the next folder is CMake. You may know what this is if you have already played with big libraries. Personally, I'm thinking about the OpenCV or the ones used for computer vision. And in our case, it is mainly used for GitHub integration. So once again, we don't really need to take a look at this, and it's just there for a reason. It's not part of the actual code. So this is not running your printer. This is simply for GitHub. And we then have the core. So this is where almost everything on the board happens. So we can directly see all the serial communications related stuff. We have 4 different files for that. There's also the USB communication setup. There's an allocation of an IP address to the MMU2. And all these files, they are interesting to look at, and they are a bit useful, but in our case we don't really need any of that, so for a few reasons. So first, we don't need any serial communication because we have a single board and we don't need to communicate between the two of them, and also because Marlin already takes care of most of those, so it's already implemented into Marlin. Okay, and the next folder is the one that was the most interesting for me, and that is the most interesting for this entire project, because this is where all the physical interaction, so the outputs and inputs and all that kind of stuff are happening. And this is what we're trying to reproduce in Marlin. So the first file then there are all the buttons control related files. So all the files from button 3 to, so abtn3 to buttons.h are related to the physical input that are on the original MMU2. So in our case, we don't have any physical button on the MMU2, but we'll be able to reproduce them in the firmware inside Marlin. So the button file also has other functions like controlling most of the LED status, which are not present on my modified MMU2, but also other important things related to the button, like setting the button length manually. So basically have a single function that we absolutely need to reproduce in the software at first, and it will most likely be defined with a variable in the code, and then I will work later, when everything will be working fine, on making them easily modifiable in the firmware, so on the printer screen directly. So inside Marlin, basically have a little folder like the different configuration folders that you may see on your printer screen, and be able to set all these settings in there so that it's easy for the end user to actually get in there and tinker a bit with the different settings without having to code anything. Okay, so now let's take a look at the next files. So the config file is pretty similar to what you would find in Marlin. So all the pins, baud rate, status, the different stepper motor controllers, mods, and a lot of other stuff is defined. But most of these are already in Marlin, so we don't need to put much work on that. So the next file is related to the stepper driver that are on the board, so on the original MMU2. So in particular, the Trinamic stepper drivers. So these are all the TMC2130 drivers that are kind of famous and really used in all Prusa products. at least most of them. They're not really cheap, but they are great quality, and they are also used in the MMU2. So this is also included into Marlin because Marlin supports a lot of printers, and some of them run TMC drivers. And in our case, it will be even less of a concern since we're only using A49AA drivers because they are way cheaper, and we are still trying to keep the price low. So that's why we're going with those drivers. I may do a second version or improved version where I use more expensive parts. And you may know that there is a pretty big difference between the A4988 drivers and the TMC2130. It is with the homing. So when homing, you have a feature with the TMC2130 is that you have centralized homing. So basically, in our case, the part that we need to home is the idler. The idler rotates until it hits the end stop, and at that point, the current draw increases because there's a resistance on the motor, and this way the stepper controller knows that it has reached the end point, so to say. So this is not a feature that is in the A49AA drivers, so we will have to use an alternate method for the homing of the idler motor. So I will most likely go for a switch like
Okay, so this is future me, and I want to give you a clear explanation of how everything works. So basically you have the motor that is connected to a TMC2130 driver, and it rotates until it hits the end stop. Then once it hits the end stop, it cannot move, but the motor still tries to push the idler. So the power draw on the motor increases, and at that point the firmware says, okay, this is my home point, and I just have to do, let's say, like 2 degrees to the left to get into the first filament, and more and more and more, and then we basically have the position of the idler with all its bearings, and we know what position we need to select the different filaments. So how am I going to know its position if I don't have a TMC2130, because these are like $10 each, or a bit, like, they're really more expensive than the A4988, and the A4988 is what I have, so I'm gonna try to avoid having to buy an extra stepper motor driver. So basically how it works is you have what I'm trying to do is design a slot for a switch that would go right where the end stop is, and it would work exactly like the axis on your printer, most likely. It would just like go down there, press the switch, stop, and then we would know the position. So that's what I'm thinking to do to this, and video coming up on that in a week or so. So yeah, that's about it.
Okay, so next is the line ending management script. We don't need to reproduce any of this since it is already into Merlin, like most of what we are seeing in this program. So the following file is a key file of the project, as the name implies. It links together all the other files. So the first few hundred lines of the project are related to the LEDs, so basically to signal the state of the MMU to the user. We then have a function to check the presence of the filament and to signal its absence if it is not here. And we also then have all the different drive errors and also the unrecoverable errors. And then we have the setup function. So this works in a few steps. So basically it initiates the MMU2 as the name implies. And it mainly is signaling that the MMU2 has been activated with the LED, so this is signaling it to the user. Then it is starting the serial communication and sending a start message. So start with /n, so line end. And then it is checking if any button is pressed and starting the homing sequence from the TMC2130 and it sets the idler, so this is the part with all the bearings on it, to the selected filament, and it also checks if the filament is already loaded, so if the inductive sensor is triggered. So the next function is to manually select the extruder. So the filament chosen by the printer, so the filament chosen by the printer, and this is not really necessary at the beginning, but I will want to include this later in our firmware, so that we can still print normally without changing too many settings in the slicer, and still be able to have all 5 filaments loaded and be able to choose the material of the entire print without having to change the filament spool. So be able to easily manually select which filament you want to use. The next function is the main loop. So the printer first processes all the different comments that are sent by the printer board, so not necessary in our case because we don't have any sort of communication. We then have a switch using the argument state, so this will go through every case, and the case is basically what the value of state is, and if the case is true, so the value of state corresponds to the value of the case, the code linked to that case will run. So the different states in there are setup, printing, signal filament, idle, wait, and wait OK. So the case setup and signal filament just check if the printer is still in the related mode, and if not, it brings the state back to idle, because this means that the task running has completed. So for the setup menu, this would mean that the user has exited the setup menu, and it brings in back to the state, so it brings back the state to idle. So the idle state calls the manual extruder selector function, so that gives the ability to the user to select the correct filament. The wait case is basically an error state, so contrary to what its name may suggest. So it signals a load failure and signals it to the user and waits for an answer. The wait OK is used when the user signals that the error has been resolved, and if it is the case, it sends the printer back into the idle mode. So the process comment function has been called previously in the program, so yeah, we can just scroll on top to go see it. And it is called during the setup, and it does exactly what the name says. It processes the comments and calls the right files and functions from the rest of the program, but it also does some minor processing, like changing its step or driver mode. So MMU2 controls the change of materials and the different filament unload and reload. Motion controls most things related to the stepper motor's movement. So homing of the different motors, so the idler and carriage in that case, but we are not using a carriage in the final version. Checking for motor related issues and the different motions that are required, like feeding the filament from the MMU2 to the extruder. Then we have the file permanent storage. So this stores the configuration and most of the settings permanently, so on the EEPROM. So these informations are also used for a lot of things. So as an example, a good example would be a power outage. So this is used to get the information needed, like position of the carriage before the power shutdown and the status of the filament that is loaded. So I don't really need to talk about pins.h. You already know what this is all about. The HR16 is the part of the code that is related to the presence of a 16-bit shift register on the board. So a shift register is a sequential logical circuit that can be used to store or transfer binary data. And it can have a lot of different uses, but in our case, I believe it is used to have more input, output on the board. But if you want to learn more about what a shift register is, you can go check a SparkFun video about shift registers, like if you want to learn more about it, because I won't go too much into details in this video. So the SPI file is also used for serial communication. So SPIs stands for Serial Peripheral Interface and works with slave master logic. So the master controls the slave. So this deals mainly with the communication to the other board using the TX and RX pin. And the next file, which is the stepper.cpp file, is actually quite similar to motion, but it's just closer to the physical aspect of a stepper motor, and it controls different things like acceleration, micro-stepping, etc. So the timeout file is not used in the current MMU2, that's why it's a simple comment. The TC2130 files are to control the stepper motor controller, and we don't use those drivers, so we don't need to reproduce this in our final in our firmware, so the one that we are going to be implementing, so basically our version of Marlin that we are going to be modifying. So the UART file is used to control the physical circuit responsible for transmission and reception of serial data. So you could think that UART is similar to SPI because both are kind of serial communication, but actually UART is not a communication protocol like SPI. So SPI is a communication protocol, but UART is actually a physical circuit in a microcontroller or as a standalone circuit on a board. And I think that this is our case on the MMU2, but I haven't looked at the board yet, and I won't because we are not using a separate board. Okay, so this is the end of the video. I just want to say that the speed of progress in this entire project is going to be increased by a lot now that I don't have much going on. Because previously I had a lot of stuff going on in my personal life, and now it's not the case, so I should be able to put a decent amount of work into that project that I really like. So thanks for watching, I hope you liked the video, and I will see you next time.